stay here. And so I want to introduce Carine Briand, who is an astronomer at the LESIA laboratory at the Observatoire de Paris. And you are an expert on solar physics, plasma physics, space weather.
Yeah.
Is that about right?
Yeah.
Okay.
Correct.
And so Carine will talk to us about light pollution today.
So, hi everyone, thank you for coming. I hope you're not too much exhausted by all the equation I've seen just arriving, and you have relaxed a little bit from that. So it will be much more relaxed than what you have just seen a few minutes ago. In fact, this is a new topic for me also. This is light pollution, and we, of course, as an astronomer, we are concerned by light pollution, as we will see. Well, personally, I'm not that much. In fact, I'm a solar physicist, so I don't care that much about solar pollution, light pollution, but okay. So, first question, why do we need light at night? Answers? Yes?
To be safe.
To be safe, yes. What else?
To find our way out.
Yes. To travel. What else? Think to what you're doing at night, and imagine we switch off the light. What will disturb you?
To work.
To work. That's all? I think there are many more things. So, maybe you're tired. So here is a list of things that for which we need light. We need light to work, indeed. So at home, but not only, also in enterprise. A lot of enterprises are working at night. Things about, for example, Amazon or all this kind of enterprise. The airport, fishery places. Industrial greenhouses, dans les lycées, security monitoring advisement also, for leisure, so for fun, so just to embellish all the monuments you may have, for the disco also, to go the festival, you need light also for that, you need for outdoor sport also. So many. So for those that follow the Rugby Cup right now, imagine we switch off the light yesterday evening. We still have Antoine Dupont that would play today, but okay. To travel, indeed, for street light or for pedestrian also. And for security reason, we have this fear of darkness. I mean, this is a real primitive reflex, and we don't like. We are afraid by night, except the astronomers, of course. For the crime, delinquency, road accidents, and also for emergency on the road or wherever, for firemen, policemen, or they need light to see where they should do something. So this is most of the things why we need light. So from light at night, we can extend also the time for our activity. Imagine that we have to stop our activity when the sun is down, so we will stop within a few minutes here. So maybe we need the light here, by the way. We need the light here? No?
No, we don't.
So probably we can switch it off. Because there are nice pictures also, so if we don't see the lights, that comes from the moon, the first one, the stars, the Milky Way, the air glow. So there are a lot of natural light. But there is also light generated by the human activity that largely increase the sky brightness, what we call the sky glow. And the light pollution, by definition, is when the sky brightness is higher than more than 10% of the natural brightness of the sky. So you've got a nice picture here. Should have switched it off. This one. Does it work? Yes? No? No. Okay. It doesn't work. So just air glow, sky glow. Air glow is a natural the light that is emitted naturally by chemical processes in the atmosphere, while the sky glow is the light that is scattered by the artificial light that is scattered and that generates some domes over cities. Do I have the, yes, my pointer is here, I think, is here. Okay, so here you've got an image of a dome light over a city. You will see this picture quite a lot. This is on my house in the middle of Bretagne. You will see some result of that. So this is where we should be with large, you see how the, yeah, we got disturbance. Even in this room, we cannot see the dark sky we should have. And what happened more and more when you've got the cities that just destroy the visibility of all the stars and all the structure we can see on the natural sky. And you've got an example right now. What are the physical processes behind that? There are two main physical processes, which is called the Rayleigh scattering and the Mie scattering. The Rayleigh scattering occurs when the particle size is much larger than the wavelength that is scattered. And this is efficient mostly on the blue side. I mean, this is the efficiency of the scattering is 1 over lambda to the force. So as the lambda is small, the scattering is increased. That's why we got the blue sky. And this is in almost all directions. The Mie scattering, on the opposite, is just depends like 1 over lambda, so less strong frequency or wavelength dependence. It's scattering in the forward direction compared to the direction of the emitted beam. So this is what is generated by in the near cities, and due to atmospheric components, molecule and air aerosol also. So this is a suspension of all the solid particles or liquid. Well, another term, this is also air pollution. So stronger air pollution, also stronger Mie scattering. So this is, I've already mentioned two dependence on the scattering. So the type of lighting, we will see that in a few minutes. The presence in nearby cities and meteorological conditions, when you have clouds or not. We will see that in detail. So first, let's see what's happened with the type of lighting. There are several types of lighting, artificial lighting, of course. So, do I have my pointer? Yes. So the ones that were used up to now are called LPS for low pressure sodium, or HPS, the high pressure sodium. So you've got here a description of the spectrum for each lamp. So you see that LPS or, oops, sorry, come on here, LPS or HPS, LPS particularly is very narrow band. You got only around the orange emission. HPS, you got a little bit more extension into the yellow or red, but still this is very narrow band spectrum. And now, since a few years, you've got LEDs that arrive on the streets. And you can see all others are LEDs. So you see that one kind of LED, the NBA LED, which is for narrowband amber LED, are very similar to the ones of LPS. The spectrum is very similar, a little bit broader, but still located in the orange-yellow band and rather narrow. But all others have a very broad yellow extension, in the spectral extension, and for the ones that have a color that is of about 5,100 K, you see that you also have a very strong blue peak. So this color, this is called the CCT, so correlated color temperature. In short, we usually speak about the color temperature of a lamp. So this is the temperature of black body irradiating at this to give the same spectral range. So you see that the larger the color temperature, the broader the spectrum in the yellow, and a very strong peak in blue. Insist in that. If you're just to give an idea of what it means, so this is a difference here between low pressure, LPS, low pressure sodium lamp, and LED for the same road. So you see the impact, the difference of brightening. And here for different color temperature of different lamps, from the yellow to the white, very bright white lamp. LED in particular. So LED are very in fashion for two main reasons. First, economic reasons. They are low consumption lamps, and that's what people, all the politicians will tell you. So for example, and this is true, for a 6.5 watt LED is similar light of 50 watts. You can have you can earn up to 87 energy for the same amount of light provided. So that's good. So you will make a lot of economy, and that's correct. And you've got an extended lifetime for those lamps by almost a factor of 10. So your consumption is reduced, and you increase the lifetime of your lamps. That's great. I mean, and for the comfort also, that's true that, well, they don't have to warm up. Maybe I made a mistake once. I put this lamps that takes a while before to warm up in my kitchen, and I was going to the kitchen, switch off the light, coming back, and to wait 5 minutes before having a light. That's really amazing. That's not comfortable. So they don't have to warm up, and in fact they mimic the high temperature ones mimic quite well the daylight. So that's quite comfortable when you want to work or to walk. That's quite comfortable. That's true. That's why they are very in fashion LEDs. Now the more complicated, I would say, part of the talk after, it's okay. So just some definition about the units that are used for to qualify the brightness of a lamp. So there are two approaches. One, this is what we call the rheometry. So this is, I would say, the absolute values of things. You measure really the energy per watt and in the electromagnetic spectrum you have. The photometry is more linked to the sensation. I mean, this is more a sensitivity of the human eyes, and it's related to that. So this is two different approaches. We will discuss more about photometry along all this talk. And I wanted to point something, preparing the talk. In fact, I realized that it was not obvious. I said, they were saying wavelength is different from colors. So, wavelength is color. But no, not from our eyes point of view. Because you can create different colors. You can create yellow from red and green. So you can have the sensation of yellow, but because you've got red and green. So it's not perfectly wavelength equal color. And these 3 units we're using, the first is lumen. So lumen is, you can have a look to this graph here that describe it pretty well. So this is the amount of light the source, the lamp, can emit, wherever it is. So all the capabilities of emission. Then you've got the candela. This is the lumen per steradian, so per angle. And you've got the lux, which is the lumen per square meter. How spread is your beam of light. So lumen is not watt. Lumen is the brightness of something, and while the watts are the consumption of your lamp. So this is different aspect. This is important also if you want to buy something. To make some measurements, what we usually use are two things. The illuminance, which is a lumen per square meter in lux. This is called the illuminance. Or the luminance, which is the candelas so the candelas is the amount of light in a given range of angles, candelas per square meter. And this is quite used, you will see in the continuation. Okay. More or less, got it? This is more complicated part of the talk. So if it's relax after that. So, why do we care? What's wrong with lamp? I mean, I want to have some activities in the night, and what's the problem with that? I mean, first we'll see the problem for human health. So first, human eyes, and more part of the animals also. We've got two types of cellules, the one we call rods, so the bâtonnets, and cones, les cônes. So in low light condition, this is the rods. So those are, you've got a picture here. Oops, got it. Okay, rods are those ones. They are used when the light is very low. So this is what we call the scotopic vision, when the light is very not intense at all. And the cones are used during the day, and they allow you to see the colors. And in fact, you see that in human eyes, you've got much more rods than cones to see, because you need more cells to detect the light when this is dark than when this is day. So the daylight is called the photopic vision, or scotopic, photopic. And in between, this is mesotopic, mesopic vision. So the rods are sensitive in the blue part. More sensitive in the blue part, and don't have any sensitivity above 6 in the red part. So keep that in mind. And you don't have really, that's why you don't have a really perception of colors when you are at night without light, artificial light. So what can happen with too much light in your life? First, phototoxicity of the eyes, especially in this range of wavelengths. So you've got eyes alteration, you have a reduction of your field of view, DMLA, I'm not sure it is a term in English, but DMLA in French. Visual field reduction, it can go until blindness. You've got, and this is true especially for color temperature that are much brighter than the 6500 K. And you will see it's a lot, and we will check later on that is not that hot. That's so much a lot with some measurements we will do later on. The second thing is a disturbance of your circadian rhythm. You know what it is? You've heard about that? So this is your rhythm, the cycle of your body during day and night. You got an illustration during all the exchange between day and night. Your body is doing things without, you don't know what he's doing, but he needs that. Especially it needs things for memory. It needs things to go. Here you got the melatonin secretion starts where is my pointer? Here. At 9 p.m. you've got a melatonin secretion start to enable you to go to sleep. So all this activity during day and night must be, this cycle must be conserved for you to have a good health. And of course the presence of more light at night will disturb part of it. So the melatonin rhythm, this is a sleeping quality, and the impact of light is now recognized. I will give you a list, the list of the bibliographic studies I've based my talk. And this is from the ANSES, so l'Agence nationale pour la santé, etc., that said that this is recognized. So you need a large difference between night and day for your cycle to be okay. So this is disturbed by clear night, but also by dark day. What I mean by dark day, imagine you're in winter. It's easy to imagine because it comes very soon. You leave home, it's dark. You enter the subway. You enter in your classroom, no windows. You stay in the dark still. You spend the day here. Maybe at midday you will have a few minutes outside. You come back to your classroom, still on the dark. You leave, it's dark, it's 5 o'clock and you take the subway, you go home. You haven't seen almost the day, the light of the day during a full day. And this can last for quite a long time. So, and imagine also so for artificial. So this is what I mean by dark days. So this is something that is very sensitive to season, of course. It doesn't occur during the summertime, where you can have more opportunity to be exposed to the light. What are the consequences of that? This is strongly suspected, not proved formally, but strongly suspected. So you can have hormonal cycle disturbances, cancer, breast in particular, and skin, AVC, des AVC, psychic health, mental health, cognition capabilities, and for some kind of diabetes, you can have also some issues. So you see that is not nothing. I mean, that's to be taken seriously. Also, it can affect the development of the fetus and have some consequences once the baby is born. So once again, this is strongly suspected. And this is something that is age-dependent. The blue filtering decrease with, increase with age. I mean, where I am more able to filter the blue than you are. So in other words, you are more exposed than myself to the blue part of the spectrum. So something to be also considered. And when are we exposed? We're exposed almost all the time during the night. So there are different things. The light that enters directly to your home and your bedroom in particular. The glare, so l'éblouissement, directly from light coming from everywhere. Sky glow, because the light is sent towards the upward and reflected back by the clouds. So here is all the kind of things that can make your life more complicated. And in fact, and you see an example also of kind of illumination you can be submitted to. 99% of the US and European population lives under light pollution skies. That's enormous, almost everyone. And 83% of the world population. So that's almost everybody. And 60% of the Europeans and 80% of the US citizens do not see the Milky Way anymore. Have you ever seen, you have seen the Milky Way? Huh? Never? No. This is a message for you. Huh? You have to send them somewhere for. Yeah, they must. Okay, you see, this is not a joke. I think it was 1/3 of people that say no in the room. likely. So we are a small number here, but we are in the statistics. It's beautiful, huh? You should see it. So, for human health, done. Biodiversity, okay, why? So, the world, in fact, is a very complex world. What I mean by complex, I mean that is not because you understand each part that you understand the whole. Okay, so there are a lot of interaction, and one depends on the other. If we destroy one, we will destroy what's happened at the end. So never forget that. This is a complex world. And so natural light cycle, I need it for many things. Orientation, birds, but also ocean animals like turtles, for reproduction, for feeding, find the prey or find the food, photosynthesis, and once again, the circadian rhythm as human. And we have to know that 23% of the world land surface experience light pollution of the land, not only the cities. What are the threats on? So why do we have some issues? Because of the fragmentation of the habitat. When you've got a road that crosses in the middle of a forest, you put light, and so you will fragmentate all the habitat of the animals. So this will give a modification of the system prey-predator, because, well, the one can be on the one side, the other on the other side, and they can never meet. Modification of the reproduction cycle. This is true for animals, but also for plants. Second, this is when you've got this road or this light, this is a barrier with an attractive or repressive effect, both. So there are some animals that will say, oh, I have to escape of this zone, so you will reduce the habitat of these animals. And others are, on the opposite, attracted by light. I think you have all seen some mosquitoes or insects around lamps during the evening. So here they are attracted. So this is good for some animals. Bats, for example, will come and say, oh, I know where I can have my lunch, my dinner tonight. So they go, but you destroy this alimentary chain if you destroy much more insects. So this is really an issue. And you've got a lot of animals that are sensitive to the blue. So this is 60% of the invertebrates and 30% of the vertebrates that are sensitive to the blue. So if you increase the blue, it is if, like, I was flashing that in your face. You will not appreciate at all. If I say, well, just move, and you got that in your face, won't work. So that's what we do for them. So example of disturbances, there are a lot. I just took that, but there are many more. So birds, for example, you extend the time for their song during dawn. But of course, they will be very tired at the end, and you will reduce their lifetime. Sexual maturation that is advanced also. So this is very few examples. I stopped because the literature on the subject is huge. But don't forget, so that's quite obvious for the animals on the ground. But never forget the marine fauna and flora that is also concerned. Why? Because you've got the fishing and the light fishery. Even if it is temporary, those ones, the boats are moving, so this is very, very local. But still, you've got other kind of disturbances. This is offshore, the platforms, or the coastal cities that are permanent. And here on the bottom right, you've got a nice view. If I find back, here it is. Here you got, so I guess this is England, but I'm not sure. And you've got here all the light on the coast. You see, that's huge. And this The graph on the right illustrates all the social disturbances. In fact, all the marine life is determined, so the vertical motion of planktons, the pre-location, the communication, is determined by the colors, the profile colors with depth. So if you disturb that, you will disturb all the communication, pre-location, and so on and so forth. So biodiversity is very strongly impacted by all the aspects of light pollution. Why do we care? Third reason, astrophysics, of course, I cannot avoid to say so. So we've got the proof here that it is necessary because some people have never seen the Milky Way. So some definition, we use magnitudes, so I hope you've already heard about magnitudes. And in fact, well, if not, this is what we use to define the night sky brightness. You will heard about NSB. This is a term that comes very often. This is magnitude per arc-second square. This is a logarithmic scale, sorry. This is a non-SI unit. And it gives you, if you imagine that you got in a 1 arc-second, 1 magnitude star, n NSB means that you got n stars of this 1 magnitude in these squares. So you imagine that as NSB is higher, you see more stars, so it's better. So the higher the NSB, the better the sky is. Just to remind you the magnitude of some classical stars around 1. This is Deneb, Pollux, and Antares. Well, I will skip this D-band. So the darkest night are about 22 magnitude per square arc-second square. This is a value to remember, about 22. And this is logarithm. Logarithmic scales, this means that we will really, the range of, the extension of the values is very short. The sun is magnitude minus 27. Okay, just to make it a little bit more concrete, I think this graph is better to understand. So the dark night is here, about 22. This means that in candela per, millicandela per square meter, you're here. On the visibility, you see all the details you can imagine. Absolute visible magnitude, you see stars up to magnitude 7, and number of stars about 6,000. Now, as you go up, so come back to these values, let's say you're about magnitude NSB 19. 19 means 2 millicandela per square meter. We're in the limit, we are not with the photopic daylight vision, neither the scotopic nighttime vision. We're in the middle. So we're very tired by the eyes. How many stars can we see here? So I'm pretty bad, but I think it reached 1,000 or something equivalent. I'm not in front, so I cannot do it properly. But you see that the number of stars you can see is reducing very, very fast. And if you got something about 17, then you got 100 stars at maximum. So remember this value and what's called the Bortle scale. So 1 is very good, 2 you can observe normally quite easily in the normal sky by eyes, and here of course is not. And you see that a lot of lines that comes from this satellite that has been spread. And here another example where you see all the lines. This is not normal. Huh? Was not existing 10 years ago. 10 years ago, you don't have these lines. It's not normal. Don't take it as something that, well, it's like this. No, it's not. So this is a constellation of so small satellites that are very clearly visible, even in Paris. A colleague of us is making movies of this launch of satellites from Versailles. So you see that it's very, very bright. And there are 40,000 of those satellites that are foreseen in the coming years. So this is really, really a threat for all astronomers and also for people. And I should mention, I won't insist in that, but not only the visible sky is polluted, but also the radio sky. But this is another topic. And fourth, why do we care about that? Once again, if you're not convinced. Well, because light pollution is increasing very fast. So this is the light pollution, the situation in 2014, where you see that all orange point Milky Way is invisible, and the red, the sky, night sky is never reached. So you see that in Europe or the east coast of America, of the US, are very, very polluted. And in fact, I mentioned explicitly this paper of Kiba in 2023, so a very recent paper, and shows that the light pollution is increasing by 9.6% per year. This means that someone that is born now, when he will turn adult, instead of seeing 250 stars now, he will see only 100. So a decay that is very huge. And this is for values from European and US countries. I would say that in Asia, the situation is probably even worse. You have seen a few slides before, all these illumination for advisement that are really growing very, very fast. And you may see in many sites, websites or publications that there are only an increase by 2%. The difference is due to the fact that the 2% comes from satellite measurements, and we will come back to this limitation in a few minutes. But first, satellites are blind in the blue. So they don't see the blue. And they don't see what is horizontal. So this is this ultra-bright billboard for announcements. You may have building facade and so on and so forth. So there are a lot of things that we do see from ground. This is a first study, and it was a citizen science study that we can capture from the ground that the satellites cannot see. So that's why you got this difference of estimation. Are you convinced that it is important to take care of light pollution? Yes? Yeah, I hope so. I did my best, at least, to convince you. So what next? What can we do? That's terrible. I mean, I will be sick. I won't see the stars and so on. So there are some options. So first, as scientific, the first thing is to measure and to model all these things, to follow the evolution and to be able to say we are taking the good direction or not. So measurements, I just mentioned it a few minutes ago. So this is with spacecraft. So this is nice because in fact, what you do with cameras, you take the upward propagating light and you measure it. You got large field of view, so you can scan large region very fast. The spatial resolution is not that bad, 0.5 kilometer for the best, and the bandwidth, so this is above 500 nanometer. The bias of those measurements is that your bandwidth is above 500 nanometer, so you're blind to what's happened in the blue. You got some zones that are so bright that the camera is completely saturated. You measure only during the darkest part of the night and not during the dawn, for example. In fact, the spatial resolution, 0.5 could look fine, but is not that much. If you want to see the offshore platforms, for example, they are not that big. Hopefully. luckily. So is radius is not that good, 0.5 kilometer. And when you got long survey, because you can measure that only when it is not cloudy, so you have to take time to take your measurements, you may have difference of calibration of the satellites. But okay, it has been done and still done. Second one by airborne sensor, so better, a good spatial resolution, but difficult to have a long-term survey because this is just aircraft. And then you can go on the ground. So I will discuss the green part, the ground-based panchromatic sensor, and I will insist in that a little bit more. This is what we call sky quality meter. Here it is. So this is something that costs 150 euros that you can all have. And we can make a lot of science with just that. We will play with that later on at the end if you want, if it's dark enough. So this is a photometer. It integrates the flux light over a given angle. So here this is 20 degrees. In the wavelength range that is quite broad, you have here the spectrum covered. It is here, and to remember, the 4000 K LED spectrum is in the dashed line. So you see that we cover most of the spectrum of the light we want to measure. That's fine. Field of view, okay, I already said. So you can buy it easily. And on the right, you got the same instrument, or equivalent. In fact, this is that. But that takes measurements every minute for 10 seconds for all the night automatically and store the data. So this is this instrument called Ninox. It's developed by an enterprise we are working with, which is called Dark Sky Lab. You will heard about that quite a few times, and I'll show you some results. C'est tout? Wow! So, we got an issue. So, I have to skip a lot of things. If we have got only 5 minutes, so the modeling has skipped it. So, example in France, I want to show you some example anyway. So, here, this is in Meudon. So, this is what we observe in Meudon. We are here, so we are very bad. So this was taken this year. Here you can follow the moon. And the bump is due to the moon arriving. And the clouds, the influence of the clouds. And you can see that so the light pollution is increased because of the presence of the clouds. Because it's just reflecting back all the light. But you can see also something here. This is the extension of light in Meudon. So here you see that the night is improving a little bit here. So the switch of the light, and the quality is decreasing here. The switch on the light, and this is even better seen when you've got clouds where you got bloom difference. So you see the impact of the light extension is stronger when you've got clouds. So I wanted to show you, but I don't have time apparently, so if people are interested, I can show you some results obtained in a rural zone. So this is my countryside house, family house. So there are some nocturnal extension. We see on the backyard I put the Ninox, and we've got, I observed 3 sites. 2 of them have a rather good quality, 21.5. So if you want to make some astronomy, in fact I started astronomy over there when I was young. And even in another location, this is even better. This is more than 21.50. Something that I have to take care is, once again, the light temperature. And this is, we can play with that in a few minutes to determine what is the color temperature of all your cell phones We'll do that later. You will be surprised. And by that, also, you will be surprised. This is nice, huh? We have all these kind of things at home. This is mine. But this is bad, in fact, so I switch it off. So take care, and this one is, of course, bad, bad, good. And this city is good because they put it, this is a light in the center of the small village. And how can we reduce the light pollution? So the political regulation first, this is really very important. Who is concerned? All people, I would say, that have some activities, commercials, zone of activity, park, monuments, ecological reserve, and so on and so forth. So this is French application of the law here. I'm discussing only French part. So this is an arrêté of the 27th of December of 2018, if you want to have the details. So first, the limit, the inclination of the light should be directed downwards and cannot be higher than 2 to 4 degrees from the horizontal once they are installed. And there are also some flux maximum that can be attained. There is no regulation of the light that enter in your bedroom, unfortunately, yet. Light sources also. So the lights must have a color temperature below 3000 K. So these kind of LEDs are not allowed in the street normally. Now you know. If you got a spectrometer, just check. I did it, and I went to see my mayor and say, well, this lamp, I don't want it anymore. This is bad. She said, oh, she will do. Also, the time where you can have some lightnings is controlled. So this is not, I won't enter in all the details, but you've got really strict regulation about that. So if someone is not doing that, you can complain and say, well, you are not allowed at 2 a.m. to have your light of your commercial on. It's completely forbidden. Another kind of political activities is to have some labels. So there are one label in France, Ville et Village Étoilés. There is presently more than 700 cities that have this label. So you can go to the site of the ANPCE. L'Agence nationale de protection du ciel et de l'environnement nocturne. This is supported by the Ministère de la Transition énergétique. And also there are some activities towards a label, de patrimoine culturel immatériel de l'UNESCO. So let's hope we'll succeed. Second is to create what we call the RIS, Réserve Internationale de Ciel Étoilé. So this has been created by an American initiative in 1999. There are 20 in the world and 4 in France, which is not bad. So you've got les Cévennes, Plateau de Mille Vaches, Alpes Mercantour, Pic du Midi, bien sûr. And there are 2 others that are on the process to get this label, le Grand Besançon et le Plateau de Doubs, where there are strict restrictions for the development of those of the activities. And now, this is something that is very interesting. Have you ever heard about la trame verte, la trame bleue? Yes. So. Trame verte, trame bleue, so I translated by Green and Blue Network. This is to create some corridors, the continuity of corridors in the land or the water for the plants and the animals to be able to go from one site of biodiversity to another one and not to park them in one site, to avoid what I explained at the beginning, all the issues on biodiversity. So there are a lot of activities around that. So if you're interested, you can go to that site in the website. It gives you all the information. So there are plenty activities around that on different cities and different groups. So the idea is to have also the black network, la trame noire, to avoid to put some lamps or some lightnings where you try to preserve the biodiversity or to do somewhere else. So also to have exactly the same corridor of black light for all the animals to be able to move as they want. So that's very important, and that's something that is relatively new and not so developed. So if you want to participate to something, there's a lot of work to do. How to reduce light? Well, it shows we can also play a role. So it's easy. Just use lighting only when it is truly necessary. Sometimes I'm fight against people who say, well, do you need light? Oh, no, well, switch it off. Care on the light temperature now. I hope you're convinced of that, and you will play with my lamps a few minutes, you will see. Or if you want really to use that, just close the curtains.
If they close it.
Yeah, we cannot, so I won't switch it on. But just close the curtains, and it's okay. You can live, except for the health problem. And act in your environment. Educate people. I don't know if there are some people from the observatory listening right now. So if you're interested, join Esther's too. Private message. And a lot of activities also, what we call citizen science. So there is the Global at Night, which is Globe at Night, which is an American association that makes some campaigns to help to, because we are numerous, and so we can have a lot of information, a lot of data. So it's very easy to use. So go to their website, you will see. They provide you with a map, and you say, well, I see this, just that number of stars, or much more. And this gives a number of the quality of the sky. Maybe if you go from some internship training somewhere, you can also take the advantage to do that. Okay, summary. So we're almost there. So of course, light is mandatory for our activity. We cannot just say, well, I go to bed when there is no more light outside. But the artificial light have increased too much and have really bad consequences for all life on the Earth. So we're really to take care of that. Of course, LEDs are more economic, so there is what we call a reborn effect. If it is less economic, I will put more. This is like the TV screen. When I was young, they were that size. Now they do not, the consumption is low. They are that size. So this is the same consumption, in fact, at the end. So this is a rebound effect. So we have discussed all the negative impacts of the overwhelming light, in particular in the blue. But there are still many research to do. The security aspect, we mentioned that at the beginning. I have to say a few words about that. It's not proven at all. If you want to install in a house, you need some light. Or if everything is dark, you will take a light and everybody will see your light because you need that to open the door. So it's not proven at all. And I've seen a few papers and none of them were clear on that field. So else, worker protection, there are many work to do also in that. Biodiversity on land and marine fauna. And sociological impact and cultural impact. I haven't time to discuss about that, but remember that a lot of society were based on cycle due to the stars. So all this culture is just removed, and there are very few studies on that. And now the new threats are, the future threats are the private light, like the greenhouses, les serres, that are really exploding and are based on lightnings, very strong lightnings in the blue in particular. well, everywhere in the north of France in particular. Some hope. I won't let you go saying, once again, a bad story. So in France, the situation is improved. It's not just an effect of the fact that this is taken by satellites. There are truly an improvement of the situation in France. It's getting worse in other parts. And light pollution can be stopped very quickly. The recovery of the biodiversity is not that quick, but at least we can stop the pollution very quickly. It's not like air pollution, which takes more time. So that's a good thing. City policy can easily help. So we've got a large number of cities that are now switching off the light during the night, and large cities also. Bordeaux, Lyon, Strasbourg. So security issues apparently is not so much an issue over there, or they would stop. I mean, this is huge cities, not very small ones. Yeah, and there are some professional and associations that discuss together. That's very important. Industrials of light that discuss together to try to find some solution. To go further, I just want to mention a few associations in France, if you want to go further, that with whom we are working on this topic, except the US one, but okay. And coming soon, so if you want to participate to something, there is La Nuit est Belle au Grand Genève, so the 20 tonight. Realize we are the 20. When I prepared that, it was a few days ago. If you want to follow, and they extinguish a light from Genève to almost Lyon. So that's really a big extension, partial or total, but big one. And le jour de la nuit, national, this is 14th of October, and we will have some observation in Meudon. Okay. So c'est Mathieu Servia qui s'en occupe. So if you want to have a look, so éteignons la lumière et rallumons les étoiles, s'il vous plaît. And this is finished with biography and website.
Thank you very much. Okay, so some of you can leave soon. If there are any questions, maybe people on video as well.
And for those who want to play a little bit, you can take your phones, cell phones, and we'll have a look to the spectrum of your computer or cell phones, or if you want to play with the light, maybe we can switch on the light, and you will see also those ones that are very useful to can come and play with it. What do you think about this light? Is it good? Bad? Terrible. So I make the measurements. Where is it? Measurements. Any questions? They are all dead. So here is a spectrum of the light above you. So very blue. And color temperature 4,000. Someone want to try his cell phone? Or PC?
Sometimes we can put it into the red mode, right?
Who want to test his PC or? Sure,
I have
just.
two modes because I have the red one.
So measure.
Should I put just on the
Okay, let's try. I don't see anything, so tell me if it's finished.
It is.
Yeah.
Oh, it's interesting. And
So what about the blue?
yeah.
So here it is, the results.
And then if I put the filter.
Yeah. Okay. Okay. Let's try. Is it finished? I don't see.
I don't know. It's not changing.
Yeah, it changed. No, let's do it because it's the intensity.
Oh.
I do it again.
Okay.
The intensity is low, so.
Changed?
Okay,
Oh. Yeah. It decreased.
decreased.
Yeah.
Yeah, see, it improved a little bit, huh? So it's good to. Someone wants to test? No, you're afraid now. I don't want. No question? So I hope you're convinced to take care of that, and probably to be also some, to have some activity to reduce a little bit your own impact.
Stars when you can.
Yeah, look at the stars, please.
Sometimes you just have to leave the city a little bit, and then you can
Yeah,
actually
yeah.
countryside you really see a lot
Yeah,
more.
yeah.
Okay.
Okay, thanks.
Have a nice weekend. Thank you.